And now we're very much involved, along with some other companies, in working with Docker towards new kinds of networking for Docker. So watch this space. I believe there may be some announcements next week at DockerCon. And here are some links to check out if you're interested in following up on Weave. What's interesting about Weave from a technology perspective, and that's really what I want to focus on in this talk. First of all, it's 100% decentralized. Everything in the design does not require any kind of consensus or coordination or agreement. It's all based on asynchronous techniques and very, very scalable indeed. Secondly, and this is really important, the APIs are things that you already know. We don't think it's very easy to use new technology when it requires you to believe that it will work and requires you to learn a new API. Sometimes, as with somebody saying earlier on GearD, I think was one, Kubernetes another, the technology is changing all the time and you don't know whether the API is actually going to even be useful tomorrow. So we think it's very important to adhere to best practice, maybe even decades of best practice, when it comes to the types of technologies you should use. And so with our network, not only is it a layer 2 IP network operating as a virtual switch, but also service discovery has a DNS interface, so you can already use it. And we're currently working on address allocation, which will have a DHCP-based model, actually D2HCP, because it's decentralized. And this enables us to say the following about our technology, which is that not only does it help you to solve a problem, it then gets out of your way. It doesn't constantly trip you up with reminders that it's there, trying to get you to do things differently from how you're used to doing them. And we believe this solves possibly the widest range of problems as a result. And so the question then arises, what else can you do in this way? Maybe you could build a whole operating system or platform like this. But before we look at that, let's go back in time. It's now 2014, so let's go back to 1994, 20 years ago. The first real attempt to do portable and distributed computing by Sun Microsystems, so you may remember. Some of you seem to be old enough to remember Sun. Some of you even worked at Sun, I think. Where's Finton? Anyway. It was a lingua franca for distributed computing, but it took off as a source of technology for web applications. But the distributed computing problems were not actually, hidden. They were there all the time. And the people who made Java wrote down what they call the fallacies of distributed computing at the same time to remind themselves primarily and then secondarily, you guys, what can go wrong when you build an application on a network using distributed technology, possibly using Java. I'm not going to go into great length, but some of you may have seen this before. The killers are, of course, things like latency. If you are making network calls, it really matters if you're making them over a network or not. That can profoundly affect how your system behaves. There are also things called partitions, which nobody gets right if you're running a large-scale system. So I'm not going to, can't go on. Actually, just one point about that. I say it's 7+1 myths because one was added later by James Gosling, who wrote down the first 7 with some other people. He added it in 1997. So what happened with Java? Well, Java tried very hard to solve enterprise computing problems, i.e. to sell to businesses. And businesses said they wanted safety, guarantees, reliability. They weren't so interested in productivity at the time. They were really just interested in IT being safe. Now, if you think that businesses today fear IT, you should have seen what it was like in 1994. They were absolutely terrified of technology, and they really thought IT people should hide in the back office. It was the IT crowd, but on a massive scale. So these platforms, which were J2EE platforms, are really there to make the IT crowd go away and be replaced by some software that you could buy from IBM or BEA or Oracle or Sun, a J2EE application server. And what they tried to do was hide all the complexity of distributed computing inside the platform, which turned out to be a bad idea because it encouraged people to use features that were baked into the app server that they'd been told to use by the boss, like distributed transactions and all other kinds of coordination solution, which turn out to have unforeseen effects on your application. Essentially, the downsides of hiding complexity is that it bites you later. So let's please not do this again. So coming back to the present day, some things have changed since 1994. First of all, we now have what appears to be more or less ubiquitous and cheap physical computing infrastructure. We have all kinds of clouds. Not all of this compute infra will be Amazon. I think they're 1 or 2% of the world's servers. Google, something like that too. But it is cheap. And it means that some of the problems, if not, haven't exactly gone away, but have been somewhat mitigated. For example, administration. From the point of view of an end user, a cloud is almost a zero admin solution. So the nature of the problems has changed a little. But some of them haven't gone away. I mean, latency, as I mentioned, is still a big one. And anything to do with system integrity, whether it's identity,